Hello, everybody. I've seen a kind of persistent error that I just wanted to address, and it comes when you have some integrals that involve e, and then with how you can simplify those. And I just want to address it, especially because when we do exact equations, we have a lot of integrals, and we have a lot of e things, and we have a lot of cancellation. So the first thing that I want to mention is that anytime you have the integral of e to the something x, what you're doing is you're doing a miniature u substitution. U equals 3x, du equals 3 dx, and that means that du divided by 3 is dx. So my original integral becomes e to the u times du divided by 3. And that means that I can multiply the constant of 1/3, and I can keep e to the u the same because e to the u is its own derivative. That means it's also its own integral. Throw on a plus c just for being a good little math student. And that means that I have 1/3 e to the 3x plus c. This only works if there is a linear term in the exponent. And I will often just skip from there to the answer because it happens so frequently, and the substitution is just a linear term. You just have to divide it by its coefficient. So just to show you a few more examples, if I did the integral of 5x dx, it would be 1/5 e to the 5x plus c. If I did the integral of e to the negative x dx, it would be negative e to the negative x plus c. If I did the integral of e to the x squared dx, it would absolutely not be 1 over 2x e to the x squared plus c. In fact, you can't do this integral with an elementary technique. And I don't mean elementary as in easy, I mean elementary as in functions that we know. You can't do it. You can only do it if there are linear terms in the exponent. So one last example, if I did e to the mx plus b, then I would have 1 over m e to the mx plus b plus c. Okay? So that's important. The second thing that I wanted to address is how we simplify exponents. I've seen a lot of people having trouble with situations like this, e to the ln of k, or e to the ln of x. It's the same thing. One idea is that e's and natural logs are inverses, so you just get k. But we often also see situations like what I was just talking about with the integral, where we have e to the 1/2 natural log of 2x, maybe a situation like that. How do we deal with that sort of a situation? Well, I remember that if I have a power to a power, I can rewrite that as a power times a power. And I can do that backwards. These rules work both forwards and backwards. So I'm going to rewrite this as e to the natural log of 2x, all raised to the 1/2 power. Just like in my first exponent example, e's and natural logs are inverses. So I have 2x to the 1/2 power, or the square root of 2x. You might also run into a situation like this, e to the 2 natural log of x. By the same idea, I can make that e to the natural log of x squared, which is x squared. Okay? Maybe you didn't like that explanation of it. Maybe you want to do it a different way. If I have e to the 2 natural log of x, I can remember this rule, that if I have a number in front of a natural log, I can make that the power inside the natural log. And that makes sense because the log counts how many powers of the base go into the input. In other words, when I say natural log of x, I'm saying how many e's fit into x. And if I multiply that answer by m, it's going to be the same as saying how many e's fit into x to the m. Anyway, that means that I can rewrite this as e to the natural log of x squared, and I can cancel those out, and I get x squared. If I had e to the k ln x, I can write that as e to the natural log of x to the k, and I can cancel out the e in the natural log and get x to the k. Okay, so these are sort of persistent things I've seen with exponential functions, simplifying them and integrating them. So please reach out with questions. Happy to help out.